Alright, time for another DraftPhysics.com, DebatePhysics.com also. Over and over. Circular debating. Alright, so KE versus MV. And again. So these arguments have been gone over and over again, and we'll go over them again, I guess. No real choice until somebody mans up and engages in the conversation in some sort of real way where they oppose my explanations with a counter explanation that has something in it more than or references to no evidence, because that's really all there is evidence. You got to use that to make your argument. So anyway, comment. And so, all right. So why do they use springs in the colliding carts even though Newton's cradles work well without springs? Well, the point is why do they use springs? It's supposed to work with an elastic collision, and metal on metal is often perfectly elastic enough, okay, in 90% of cases or something. It'll do a good job. So certainly I could post a link to, but I won't, because, I've already done all this shit. There's a Harvard video just showing an air track, and there's no springs on it. It's just metal against metal, and it hits the cart, and the cart goes off with all the energy. It stops perfectly dead, perfectly elastic, works just fine. Blah, 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 blah. And as has been pointed out, springs have a little bit of trouble. They collect energy pretty good, but they don't give it back very good because they end up wobbling. And that's an indication that they didn't give away all of the energy. So that's one strike against them. And second, they delay the whole interaction. So they absorb some of the energy, and then they wait until the event is happening, and then start releasing the energy, and in a 50-50 way, Newton's third law kind of way, which kind of changes how the outcome will be. So in a case where a cart would hit something and then move with it, instead you'll get a reflection. The thing will move and this will reflect because there's a spring there. So springs definitely change the experiment, is the argument. So he says, even though the steel balls are pretty elastic, the cart themselves are not. So they're aluminum in a lot of cases. They're metal. And clearly they're made to be able to take impacts. I mean, they're made to collide. So it's kind of bullshit to say they can't take it. If they use steel balls instead of springs, they could just put two pieces of steel on the end of the cart, and that would be perfectly adequate to create a nice hard impact point. The impact on the carts would be too hard, so it really wouldn't. So that's just all made up. And they would drain some of the energy, says you. So you just made that up. The combination of the cart and steel ball would not be very elastic. I would argue it'll be perfectly elastic. That's all just made up shit. Try dropping a steel ball and a rubber ball on asphalt. The carts aren't made out of asphalt. so it's just more bullshit. And see how they bounce. They're hard plastic, so drop hard plastic onto hard plastic and you get a pretty good bounce. The steel ball will not even bounce much because the combination of the steel and the asphalt is not very elastic. So it says you again, I mean, if the steel ball actually hits one of the little rocks in the asphalt, it's probably going to bounce pretty damn good. Anyway, the impact is so hard the asphalt deforms and drains the energy. Bullshit, bullshit, bullshit. Anyway, that's why they use springs in the cart. So just more nonsense. The fact is they don't need to, okay? And the fact is they do it because in combination with the bullshit little tiny metal wheels, the combination of all of these defects can force the experiment to look the way they want it to. And that's why they do it, is because it works to create the delusion of their success. But how would springs cause free momentum anyway? They'll cause it because you can have a lot more energy going in than is detectable in the linear velocity, as already explained. So if you have a bunch of metal wheels, or frankly, if you just don't give a damn about whether you got the cart's weight right, You could have a much heavier cart going in called a one mass, and it's not really a one mass, and it will create the illusion of the rebound and the reflection, even though it had more energy than you stated. So that's the fact of it, is it's used as a gimmick. You said springs are somehow inefficient. You said it also. So what are you going to take back your own words? You explained to us why it's inefficient because of the speed that the thing's moving and all that kind of crap, when I gave the right answer, which is it doesn't have anything to do with the speed it's moving. It has to do with the speed it's going when it leaves the spring. And it leaves the spring at a much higher speed. Then obviously less of the energy is going to get in. The spring's still going to have more left over. So how is using springs cheating? Well, I've already explained it. So, you're just being circular and nonsensical. I mean, I already explained why springs are imperfect in creating conservation of energy. You completely misunderstood my question about the scale floating in space. What does your questions are, you're writing a thought experiment about, well, you have a force, it's a constant force. So right there, you're in trouble, right? It's not an accelerating force. It's just a constant force. If you push on a spring with a constant force and the thing on the other side can move, well, the spring's just going to eventually expand to the constant force, and that's it. That's all you're going to get. The spring won't stay compressed unless you apply an accelerating force. You said push the scale so that it gives a constant reading. So you're not going to read anything. You can't read any constant force because there's no constant resistance to the motion. If you did this in space, if you actually hit this thing, okay, you got a thing, you got a spring, and then you have another bigger thing. This thing has a constant pressure. So yes, initially it'll compress, but eventually this will start going exactly the same speed as this. It'll be going the same speed, and the spring will be relaxed. Because the spring, there's nothing stopping the spring from putting its energy into the bigger thing. It just takes it more time to do it. But it will do it because this is a constant acceleration. You need an increasing acceleration. It's not a constant, it's a constant force. You push the scale until it reads 1 kilogram and you maintain that reading. What happens to the scale? You can only maintain that reading if you keep increasing the amount of force you're applying. So as both objects increase their velocity, you can keep a 1 kilogram on the scale, but you have to keep increasing their velocity. If you're not increasing their velocity, if it's a constant force, the spring will expand and both objects will end up going the same speed. All right. Physicists say it's kinetic energy that compresses a spring, not force. So that's my quote. He says, nope. These are not. So why, if you're saying nope, then why are you saying these are not mutually exclusive? It's mutually exclusive. It's either compressed by momentum or it's compressed by kinetic energy. So either one or the other is being collected by the spring. All right, and so we're arguing about what the force is. I'm saying the force is just momentum. You're saying the force is kinetic energy. I mean, is there any way to look at it? The object with the kinetic energy compresses a spring by applying force over distance. So again, this silly force over distance stuff that doesn't mean anything. I mean, there's no way to interpret it in the case of an explosion, like a gun. What distance are you measuring? What force are you measuring over what distance? I mean, it's just nonsense. Okay, that is what compresses a spring is all about. That's what compressing a spring is all about. Says you. Okay, it's, the distance is, again, and now we're going to go all the way back to the very beginning, and I'm going to argue, well, you're going to defend Hooke's law, then you're going to have to fight with Brozo and Dispar and Gosling, because they all say it doesn't work that way. Twice the compression is not twice the energy, it's 4 times the energy. You push it to change its length. So again, more nonsense about how obviously you're changing its length, but that's not what's making the spring have energy. What's making the spring have energy is a mechanical process taking place, where the steel is being stressed, and it's stressed proportionally is the argument by Hooke's law in the case of the inside a confined range of motion, it obeys Hooke's law. Outside that range of motion, that is too little motion, too much motion, it doesn't obey that consistency or linearity. But again, I'm not the one disputing the linearity. They are. So you're putting your comment in the wrong place. So it says, you believe 4 times the velocity is twice the spring compression. And he says, nope. Twice the velocity, twice the spring compression. Do the math. So if you believe that it's twice, okay, then how do you interpret it to be 4 times the energy? So you're right back where, again, I mean, I already did this in a video to you. So, you know, you're just ignoring the arguments made. So we'll just do it again. But clearly it don't work the way he says. And it's just bullshit. So this is, you know, I'm the one that says twice the compression of a spring, twice the energy, twice the velocity. All right, so it's twice the velocity. If we're agreeing that it's twice the velocity, and you're saying somehow that's 4 times the energy, the fact is you still have to account for what it actually does. All right, and there's no way to account for your collection of 4 times the energy. So just like the gravity argument, where I have done that over, well, I'll do that again too, just to illustrate the point. So look, I put a 1 mass on, I get a compression of this much. I put a second mass on, and I'll double the weight. Okay, so now it's twice the compression of the spring. Now how do you explain that? How do you explain this being 1 unit of energy, okay, and somehow this adds 3 units of energy? I mean, how do you defend that nonsense? Same weight, same motion, same action, same thing. How does this one only contains 1 unit of energy, and somehow this compression is 4 units of energy? How is that possible? How is doubling the weight making 4 times the energy? It's silly. And it goes right back to the gravity argument. So, yeah, I just shouldn't make that line that big. So we're going to drop the object from 4 times the height and double its velocity. Okay, you know, this is badly drawn units of distance, but whatever. And, you know, it's already been pointed out that, yeah, in the first, so let's just say it's a full 10 meters that we're dropping it, so we have a nice 1 second. Okay, so it's 1 second for it to fall that 10 meters, and then it's, well, technically, you know, that's not true, right? But it only falls 4.9 meters. All right, so the 4.9 meters, okay, of distance in 1 second. That's what the expectation is. It'll fall 4.9 meters in 1 second, and it will be going 9.8. So we'll put the 9.8 over here. All right, and then the next interval of time, because it's a time-dependent force, so this is 1 second, this is 4.9 meters. All right, and so in the next, this portion here is your big problem, because this portion here will be 1 second. You're only going to get 9.8, as I argue. Okay, that's all you're going to do is increase your velocity after you travel that full distance. You'll now be at 19.6. So you only got 1 unit of 9.8 here through this whole distance. It's just an absolute fact. You were going 9.8 here. You're only going 19.6 here. So in this whole distance, you only got 9.8 increase in your frickin' velocity. 9.8 meters per second increase in your velocity. You only doubled the velocity. Obviously, it's 3 times the distance, and you only doubled your velocity. I mean, you can't make any sense. You're going half the speed here. You're going half your speed here at this point. You're not going half your speed in the middle. So, I mean, how do you say that there's 3 units of energy here? There's no evidence that you got 3 units of energy here. There's no evidence that you're doing anything but going twice the speed. So it's obviously just twice the velocity. It's twice the momentum when you land. That's all you're going to gain. It's not, this distance thing is an illusion because you went through the gravity much quicker here than you did here. And it's just an absolute fact. You just went through it quicker. You went all of this distance in 1 second. You went this distance in 1 second. And it's just about how long you're in the gravity. It tells you how much force pushed you. You can't get pushed with more force than hit you. And it's just proven fact that you only got 2 units of force because that's all the velocity you have. So again, you just keep arguing this nonsense that somehow twice the velocity, as you just pointed out, twice the compression of a spring is 4 times the energy. Well, where does the energy come from? There's no mechanism that can create the 4 times the energy. There's no way this made 3 units of energy, because it didn't. It's just another 9.8 increase in the velocity. And the force that did it is this gravitational push. You got exactly the same amount of push here in this whole distance as it got there. It's exactly the same amount of push. So anyway, I mean, I shouldn't have to argue this. I mean, it's just, obviously there's a terrible broken continuity problem. Your theory breaks logic and physics. It breaks the sensible, rational way to understand anything. You just break it all for no good reason, to do absolutely nothing productive. Again, where am I going to get in big trouble if I am obedient to understanding it as momentum? I'm certainly not going to get in trouble in space. Navigating in space, momentum's going to give me right answers. I throw this pen out with a certain velocity. It doesn't matter what the kinetic energy is. The only thing that's going to matter is the momentum. I throw it, I'm going to get the equal and opposite reaction. I'm not going to get an equal and opposite reaction to the kinetic energy. I'm going to get an equal and opposite reaction to the momentum. And you haven't defeated that argument with anything like a piece of evidence. Nothing. And the ballistic pendulum again proves it. Okay, with all our technology, no experiment exists where they collect more than, 0.06% of the energy. 0.06%. So, what's the point of arguing about the existence of this magical kinetic energy when you can't show me an experiment where you actually can use it to do work, where it actually performs, where it actually obeys Newton's third law, where it does any of that? And the only case you can use is where you make up what goes in and you make up what goes out. As long as you have as long as you're doing an equal experiment, that is, the same amount of kinetic energy in is kinetic energy out, which means you just transferred it from one mass to another mass that's exactly the same. But in any case where you're transferring the energy to something that weighs a different mass, your kinetic energy theory is going to dismally fail to get a correct answer. It's going to lose tons of this kinetic energy. And I've already illustrated with the 10-ton train thing. You really think the 5-ton train going 10 miles per hour has twice the energy of the 10-ton train going 5? You really think if there was a tug of war between them, the 5-ton train wins? Now, we should have that experiment, right? I mean, physics should have done that experiment years ago, right? This isn't that complicated. 5 mass going 10, 10 mass going 5. That's not a tough experiment, right? But we know what the outcome's going to be, right? I know it for certain. I think you know it too, that it's going to be a stalemate. Nothing's going to happen. They're both going to just reach the end of the string. Boom. They're both going to go ba ba ba, and nothing's going to happen. One of them isn't going to pull the other one. And you know it. I know it. So why is this argument continuing? You have zero good evidence for any of this crap, this whole theory. It doesn't productively do anything. The kinetic energy theory doesn't make cars run better, doesn't make waterfalls work better, doesn't make water wheels work better, doesn't make fire hoses work better, doesn't make a damn thing work better, because momentum always gets the right answer. And again, I'm just asking you, show me the experiment where momentum fails. And you won't do it. And so that's the stalemate. So if you're going to keep just doing this circular thing, I'll just block you. I'll let you know. Because this was just circular crap. I'd already addressed these subjects. Alright, so since I'm here, might as well do another one of their contentions of this is how the universe works. So I have 2 objects of the same mass, and I collide one into the other, and I get the expected elastic reaction. Okay, so I had 100 going in, this goes to 0, and this goes to 100. Okay, so it goes from 0 to 100. This one goes from 100 to 0. So I conserve all the momentum. Everything's just fine. All right, their contention is I make this object a tiny bit heavier, 10%, let's say. Their argument is now that I have 110%, okay, of the momentum goes this way. So I'm gaining momentum by making it heavier. And I get the bonus of getting a reflection of 10%. So I threw an extra 10% this way, you know, free momentum. I mean, it's more than 100, it's 110 in momentum, free momentum. And I got this bonus of getting stuff back. All right, so I increase it to a much higher, you know, larger percentage of the mass. So now it's a 3 mass, and we can expect that I'm going to get 150% over here, and I get 50% reflection. So it's increasing. My reflection's increasing as I lose more and more momentum. So I'm giving more momentum forward than I actually have, and I'm reflecting. So does that make any sense? The brick wall is yielding. It's moving away from me with more speed, or more momentum anyway, than I threw the ball with. So it absorbed more energy than the ball had, and now the ball's bouncing back. When you know that if the wall yields, the ball ain't coming back with the same velocity. The more the wall yields, the less I'm getting back, obviously. But this is what they say is the truth. This actually happens. And if I go up to 199, let's say I'll go up to whatever, we'll say X mass, because we don't know exactly what it is, and I'll get 199%, okay, because this still moves. Doesn't move much because it's heavy, but it moves. Okay, and it has 199% of the momentum I put in. So almost twice the momentum is now moving in an object away from me. And I'm going to get a reflection of 99%. I'm going to get 99% of my energy back, which means I could just have a spring there, right, and just push it right back again. I could throw the 99% right back at it again, hit it again. You know. And so I can do the same thing, create more momentum going the other way, and I could have it hit the spring again and put more energy into the object. So I could increase this exponentially. Who knows how high I could increase this amount of momentum by just bouncing the thing back and forth into the object and forcing it to keep going faster and faster. All right, and then there's really the most idiotic of their statements is I have an X. I have a non-movable object. So I throw the thing at the non-movable object with 100 momentums. This absorbs 200 momentum somehow, even though it doesn't move and has 0 velocity. They say 200 P's went in there. It's 200 momentums. Twice the momentum went into the object and moved the whole Earth. Okay, so the whole Earth got moved with 200 momentums, and I get 100% back. 100% of the energy comes back. And that to you people makes any kind of rational sense. You really think the physical universe does that. That can actually happen. When obviously right here I can just take advantage. Just like, again, this is what they actually believe. I mean, is there anything I can, you know, how many times do I have to say this is a ludicrous theory? This is Leibnizian physics, okay? The ball bearing bounces off the hard steel anvil. All right. And it goes back up, and then gravity brings it back down, and then it goes back up, and it goes down, it goes back up, goes back down, goes back up. So it does this, you know, where it's actually bouncing, say, 20 times, where it's a decent bounce. And then the rest, you know, 150 of the bounces are kind of small. So we'll just count the first 20 substantial bounces, and with each bounce, you know, if it was 100 here, I've got twice the energy into here, so it's, you know, 200, and then it's 190, and then it's 170, and then it's 150, and then it's 130, and then it's 120 or 10, and then 80, and then 60, and then 50. Obviously I can add up all these numbers and I'll get, like, say 1500. So I put 100 in, 100 gravitational potentials. That's it. Okay, I lifted something once, I drop it, and now I get 1,500 momentums worth, okay, MVs worth of energy out. So I put 100 in, I get 1,500 out. You think that can happen? You think the free energy nuts wouldn't take advantage of that if there was any hope at all that that works? Why wouldn't every single mechanical system that we create to impose momentum, like wrecking balls, why the hell wouldn't we be banging our wrecking balls into some kind of heavier ball? Take a light one, bang it into a heavy one, and make the heavy one do the work. It's more momentum. Momentum is going to do the equal and opposite reaction. Momentum is going to knock the building down. So why wouldn't we take advantage of this free energy we could get by just having a little ball hit the big wrecking ball back and forth? Bang, 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 bang. Make the wrecking ball move with more momentum. 15 times the momentum. So we can get 15 times the momentum out of the wrecking ball by just redesigning it. So instead of the current design, just redesign the wrecking ball. Okay, so it has a little thing here with an extra pendulum, so ignore this line. Alright, well, let's say it sticks out to here. Alright, and I just swing this little ball into the wrecking ball, and it bangs into it, and bangs into it, and bangs into it, and bangs into it, and keeps increasing its MV. So its MV keeps going up and up and up and up. So I just take this little bit of work here, 100 in, and I get 1,500 out. And the wrecking ball smashes into the building with 1,500 momentums when it only started with 100. You think that's a real, I should patent it because that works? That'll actually happen? When it won't really happen. It's not going to actually happen. It's bullshit. But that's their physics. Nonsense physics. Free momentum, free energy, nonsense physics. The argument was made 350 years ago. And in 350 years, they still have produced no evidence. They've never dropped 4 pounds 1 foot and 1 pound 4 feet to prove that they're the same amount of energy. Twice the velocity of one mass object is somehow equal to one velocity in a 4 mass object. When the lever tells you, no, you need a 1 mass going 4 velocity to equal 4 mass going 1 velocity. So it disputes the existence of Hooke's law and the lever and the law of the lever, but you believe it anyway. Alright, so I guess this is just going to go on forever until physics does the experiments. Like the Mythbusters. I mean, just do the car crash thing. I think that would be dramatic enough to convince anybody, and just do it 10 miles an hour, 20 miles an hour, 30 miles an hour, 40. Just do 10 car crashes. Well, you could probably cut it in half, right? Just do 20, 40, 60, 80, 100, and see if you can find any evidence whatsoever that there's any correlation between twice the velocity and extra damage beyond twice the damage, or 3 times the damage, or 4 times the damage, or 5 times the damage. I mean, what else is going to resolve this? I mean, what other, you have no experimental evidence except these little rickety cart experiments that don't demonstrate much, because you get different answers depending on what weight carts you use. And that's it. So, we need better than this. A lot better than this. I'm sure NASA's done experiments in space that probably prove the point, but we don't get to see all the experiments they did in space, right? Somehow NASA's not open source. We should be able to see all the little, they took a ton of experiments up into space with them, all kinds of experiments. And apparently they're all owned by people who get to decide, it's our property, which is just bullshit. We pay to take the experiment up into space, and they get to patent it and profit from it. I mean, that's all just part of the bullshit here. But anyway, it's not a very good science organization. Because frankly, I mean, they have the perfect environment, and they haven't done all these experiments where you can get rid of all the wind resistance, you get rid of a lot of stuff, and they haven't done any of it. But anyway, till the next time and such and so forth and whatnot. I'll continue to look for, you know, someone who accidentally did it right. You know, like that high school teacher who did the cart experiment and it came out perfectly conserving the momentum. Yeah, that's the thing we got to find. Or even the second Professor Lewin experiment where the Velcro didn't work and the experiment came out perfectly consistent with conservation of momentum. Anyway, till the next time. Blah 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 blah. It just sucks that people. Like I said, there's enough logic to say, okay, I understand there's a problem here and it needs to be resolved with some kind of real evidence. Just the conflict between what the lever says is equal masses, equal momentums, and what you're claiming these other experiments demonstrate. Clearly the balance says 4 velocity for a 1 mass equals the same as a 4 mass 1 velocity. Clearly it's saying momentum is energy. Momentum is work. Momentum is what runs the universe. And there's no evidence that the lever can find kinetic energy, ever. Ever.